In this video, we are going to go over the first three rules of the laws of exponents. To help you understand the rules, I want to go through an example of exponential form of two numbers that you should be familiar with. Exponents mean repetitive multiplication. It is just a shorthand form that we use in math. So, for example, 2 to the fourth means to multiply the base 2 by itself 4 times to get an answer of 16. Now, if I want to multiply two numbers that are written in exponential form, I can go through one of two steps. The first is I can say to myself, well, 2 to the fourth is 4 2's, and 2 to the third is 3 2's. Well, I really don't want to write all of those out, so you should be able to see that if I multiply two numbers that have the same base, I can simply add their exponents. So the first rule that we're going to deal with is called the product of power property. And what that tells us in algebraic form is that a to the m power, a is the base, m is the exponent, times a to the n power is equal to a to the m plus n power. And the explanation is to multiply powers with the same base you carry over the base and add the exponents. So, a couple of very simple examples of this rule is if I had 5 squared times 5 to the fourth, it would simply be 5 to the sixth power. All this is a shorthand notation that is useful to us in math. If I had x cubed times x to the fourth, that would be x to the seventh power. If I had 4a squared times 3a to the fifth, what you have to be careful about is neither the 4 nor the 3 are being raised to a power. There is an unwritten power of 1, but that doesn't really come into play here. So the 4 and the 3, which you should remember are called my coefficients, can be combined to a 12, and it's the a that falls under my special rule. And then a last example, 3 to the fifth times 3 squared times 3 is 3 to the eighth power. There is the imaginary 1 there. 5 plus 2 plus 1 gives me 3 to the eighth power. Now, there are a couple of things that you have to be very careful about when using this property. First common mistake. These are not equal. The base of 3 and the base of 2 are not the same, so I cannot multiply those bases to get 6 and add the exponents. The only way to evaluate this is to evaluate 3 squared as 9, 2 squared as 4, which we know to be 36, and we know 6 to the fourth is not that. Another pitfall that you've got to be careful about. Someone sees this and says, oh, the bases are the same, so I can apply my rule. But then they write it as such. Problem there is the base carries over. This is 3 fives. This is 6 fives. I have 9 fives, not 29 25s. Okay? And the last thing you have to be careful about, four to the third times 4 to the fifth, students will multiply these exponents. No, the rule tells us that this is 4 to the 8th power. Okay? Now, one other thing that you can do, if you see how to manipulate these numbers, is suppose I said to you, rewrite 2 to the third times 4 squared as the product of a power with one base. Well, right now, as it's written, this doesn't do us any good because it's 2 to the third and 4 to the second. But if you see your numbers, you should be able to see that 4 can be written with a base of 2, 2 to the second power. That's what 4 is. And then I carry over my second exponent. So now it's 2 to the third times 2 squared. 2 squared is 2 to the fourth, which is 2 to the seventh power. We're going to get to this other rule a little later in the video. Okay? So that's the first rule that deals with the product of powers property. Now we're going to get to what's called the quotient of powers property. But I will give you the following example first. If I had 3 to the 7th power divided by 3 to the 3rd power, I can write out multiple 3's in the numerator and the denominator. Where a 3 appears in both places, I can cancel them. Well, I'm left with 3 times itself 4 times, or 3 to the 4th power. So hopefully you've now been able to see that in Rule 2, the quotient of powers property tells us that a to the m power divided by a to the n is equal to a to the m minus n. It makes logical sense. When we multiply, we normally make numbers larger. So that's why we add the exponents. When we divide, we normally make numbers smaller. That's why we're subtracting. So to go through, or to first explain the rule. So the rule is to divide powers with the same base. You subtract the exponents and carry over the base. Again, we are not changing the base in this rule, similar to what we previously saw. So, to go through a couple of examples, let me scroll down and extend. If I had 8 to the 6th power over 8 to the 3rd power, that would be 8 to the 3rd power. If I had y to the 7th power over y to the 4th, that would be y to the 3rd power. Similar to the problem we saw before, if I had 4x to the 12th over 12x to the 5th, the 4 and the 12 are coefficients. They do not have an exponent other than 1, which really doesn't have any impact. So I can simplify the 4 over 12 to 1/3, and x to the 12th over x to the 5th as x to the 7th. I don't need the 1 in the numerator. I'm just showing it to you to make things a little bit clearer to you. Similar to some of the problems that we saw with the multiplication rules, you have to be careful to not make the following mistakes. So, 8 to the 5th over 2 to the 3rd power does not equal 4 squared. I cannot do 8 divided by 12 because they're not the same base, that violates the order of operations. Similarly, if I have 6 to the 5th over 6 squared, that doesn't equal 1 to the 3rd power. The bases are the same, but this should be 6 to the 3rd. The base does not get changed. I do not divide the 6 by the 6. And then finally, 5 to the 8th over 5 squared does not equal 5 to the 4th. I do not divide the exponents. I subtract them to get 5 to the 6th power. The next law of exponents, I will again show you with a numerical example. If I had 2 to the 4th to the 3rd power, I have an exponent outside the parentheses. So what this is telling me, the exponent outside is telling me whatever's inside gets raised to the 3rd power, or cubing. Well, that means to take 2 to the 4th times 2 to the 4th times 2 to the 4th. You learned in rule number 1 that if the base is the same, I can simply add these exponents to get 2 to the 12th. Well, there's a shortcut. And the shortcut is I could just simply multiply those exponents. This is rule number 3, called power of properties. Power of powers property, I'm sorry. Power of powers property. And what that rule tells me is if I have a raised to 2 powers, that I simply multiply those exponents. So to raise a power to a power, multiply the exponents. Okay? So to go through a couple of examples here, if I have 7 squared to the 3rd power, then that simply is 7 to the 6th power. Or if I had x to the 5th to the 4th power, that is x to the 20th. It again is just a shortcut way of writing out repeated multiplication, and it'll cut down on some work and allow you to simplify different expressions much simpler.